right, you guys, it looks like people are having some trouble with this relative dating thing. And so what this is a sample that you do not have, but I will put the example up and let you know that it's a practice one. And when you look at a pile like this is a cross section through the earth, and you can see like the house, and if you were here you would be. Now, what we need to do is we need to be able to put it in order of what took place, first, and then what happened last, and things like that. And what you need is, you need to know your principles of geology. Here's that handout, and we went over these, and these are really important. And really, the two most important ones that I use the most are superposition, oldest on bottom, youngest on top, and cross-cutting relations, where if a feature like this, H, cuts the other features, H, since it cuts everything, must be youngest. Now, the other thing I'm going to do in here is you guys are going to have to be able to identify unconformities. I'm going to label the unconformities. So here's your little handout on unconformities. And so let's kind of look at this. Now, you always start at the bottom with the oldest. I'm good at these, and I can't start with the youngest. So what I do is I come down here, and a lot of you guys want to say A is the oldest, but look at A. A cuts so much stuff. In fact, A is going to be pretty darn young. Okay, you're coming down here, you're seeing a lot of cross-cutting, use superposition. Now you guys, V is the oldest. C is a fault. You see this break right here? A lot of times you can see the offset. Here you can't, because the only thing that's being offset is V. So the next thing is C. Then using superposition. You guys, I just move up using superposition, but I look left and right for cross-cutting relations. O, M, okay, I'm looking over here, X, a cutter. K, right, K is cut by E, but K does not cut E. E, that's a dike, okay. B, watch an S. Here's S. You only have to put S once. Here's S twice, but you only have to put it once. And notice, it cuts B. Okay, and here is Z, right here. This little pockets here. Okay, then we're still just going to use superposition, keeping an eye over here for my cross cutter. J, G, okay, L, F. Now it gets interesting over here, because I've got A cutting, but I've also got T cutting. Notice A cuts T. T is a fault. T does not cut A. So it's going to be T, A. Now we've got to come over here, keep doing superposition, D. Now P cuts that, P, H. Now you guys, I don't care if you get these wrong. I asked them, this publisher, to take these off. R is happening before your very eyes. N has not fallen in yet. So R, and then N is the youngest. And so if those were not on here, I think this would be a little bit more clear. Now, typically where students have problems is the start. Okay, V is the oldest. C is a fault that cuts only V. And they like to say, A or something. But if you look along the sides of A, it's an igneous intrusion. You can see it's cooked all the pre-existing rocks. So they must have been there in order to get metamorphosed or cooked. And sometimes students have problems with this one. You'll look for who cuts whom. Remember, if A's cutting T, A has to be younger than T. So notice the fault doesn't continue down here. A cuts it, A is not offset. So that's why it has to go T, A. And then if you want to say P, P is another fault, but you can see it's cutting D. So you got to do your superposition thing again. Now, real quick, I want to talk to you a little bit more about these unconformities, because you guys will have to label all of them. Now, with an angular unconformity, it's pretty straightforward. You find either tilted rocks like this, or it could even be folded rocks underneath, okay, with horizontal layers on top. You know something happened. All right, then the disconformity, I'll show you guys that. When it's parallel, you've got proof that there's erosion, and we'll see some signs of that. Now, the nonconformity is you've got the layered sedimentary rocks on top of crystalline rock. Okay, and that crystalline rock could be granite, as it's kind of shown here. It could also be schist or gneiss. These are high-grade metamorphic rocks, because all of these rock types form deep beneath the earth in kind of pretty unpleasant circumstances. And so if you've got non-metamorphosed, non-messed up rocks up here, sedimentary layered rocks, this whole event had to have been over with, and this whole thing that formed very deep beneath the Earth's surface had to have been uplifted to the Earth's surface. All right, so let's label some unconformities. You're pretty lucky because right now they've got what I call training wheels. They're shown in dark. So right here, this unconformity is a non-conformity. Okay, I've got probably what's gneiss or schist, high-grade metamorphic rock, in contact with folded but non-cooked sedimentary rock. All right, right here, what I have is I've got an angular. I've got folded in contact. They're tilted, yeah, but they're meeting at an angle. So that would be an angular unconformity. All right, right here, I have a disconformity. Okay, this pocket right here is a disconformity. And if you remember that picture of the disconformity in my explanation of it, it's an erosional surface. And you know you had an erosional surface because you've had this layer Z laid down. All right, right here, I have another angular. I finally have tilted in contact with horizontal. So an angular unconformity. And finally, right up here, shown again with the darker line, I'm not just making these up, is my last disconformity. So I will get this movie up and on YouTube too, so you can see it, and this example so that you can practice. Okay, you guys, so be good about this. This is the one you have to do, and you also have to do the one that is the last in class assignment this week. And you know, you're gonna have to send it in, probably scan a picture or fax. And so what I want you to do is you guys, first of all, like a lot of people are going to want to say A is the oldest, and I don't know why. You got to identify faults and things. Remember, faults are breaks in the rocks. We have offset. H is a fault, so H is not the oldest. It's cutting all of this. A is not the oldest. Look at all this stuff it's cutting. Okay, so this one's relatively straightforward when you get that straight. Okay, you guys, and why don't you go ahead and label the unconformities? Look at these dark lines. Practice it. Okay, I won't count it wrong or points off if you mess up, but you're going to have to label these on the exam. Okay, and here's the Grand Canyon. This one's pretty straightforward. And here's your hint, guys. K is the oldest. See if you can't figure out why K is the oldest. Who intrudes it? There's your hint. Okay, so hopefully you'll do pretty well on that one. And if you look in the weekly folder, I know you guys can't read these very well. It's schist, basalt, conglomerate, rock salt, shale, sandstone, mudstone, limestone. First of all, the inclusions tell you something, but they are not their own layer. Okay, and so what you're going to have to do is put them in order. We always start with oldest at bottom, going up to youngest. This is the way we do things because remember, superposition, oldest on bottom, youngest on top. Then you're going to have to label, there's 3 unconformities in here, all 3 types, and guess what? The training wheels are off. You guys, in real life, the training wheels are off. And I don't want brackets like this. Don't do that. An unconformity is a line. Okay, you guys, it's not, you know, a bracket. It's an erosional surface. Okay, check this out. Here is an unconformity. It's an erosional surface. Okay, and then the last thing you get to do is figure out how old that basaltic dike is. Now, this is the parent. We always do this, parent ratio to daughter ratio. And you guys, there's another video that explains how to do it. This is about as straightforward as you can get. I always give you how much parent, how much daughter, and how many years in the half-life of that potassium argon specific radioisotope. And if you watch my other video, this should be very easy. It's my example of if you can take 100 and divide it by 2 a few times, you can always figure this out.